Good afternoon, ladies and gentlemen. My name is Mr. Royce. I'll be your Algebra 2 instructor for today. And we're going to get ready for Monday's quiz. We have a quiz covering 8.1, 8.2. We have a practice activity. Back in the day, we called it a practice quiz, but at the beginning of this year, we decided no more practice quizzes. So we've changed the name of today's activity to a practice activity, even though it still says practice quiz on the document. It is now a practice activity. Now, one thing that came up in my 6th period class yesterday that I'd like to share with my 5th period class, and that is that the coffee cooling problem that we looked at yesterday is an example of what Isaac Newton called Newton's law of cooling. And this has had an impact on the history of ideas. Well, let me explain. Oh, a little noise out here. I'm back. So, I don't know if you realize this, but when Albert Einstein came up with the Big Bang Theory, he was an atheist. And this Newton's law of cooling, when Isaac Newton published, he called it the general theory of relativity. And it was influenced by curves like this. Do you know this? Is this a familiar story to you about Einstein? Have you heard this?
Who are you talking to? Like everyone?
Yeah.
Oh,
Have you heard this story
It looked
before?
like you had your focus group.
About Einstein's rejection of atheism? How many of you have heard this story before? No one. Okay, well, this is pretty cool. Because Einstein, in the early 1900s, had the view that most physicists had, and that is that the universe has not always been here. Rather, that the universe has always been here. The universe has been here forever. But then when Einstein looked outside and he saw the sun, the difference in temperature, not between the coffee and room temperature, but between the sun and the earth. I mean, you know how it is. You and I look outside and we're like, oh, it's sunny. Let's go to the beach. Einstein looked outside and he said, wow, the sun is still hotter than the earth. Therefore, the universe has not always been here. Because if the universe was infinitely old, then he knew that Newton's law of cooling said that all temperature differences would have gone to zero by now, and that the sun would no longer be hotter than the earth. So Einstein knew something was wrong with physics, and so he decided to check it out. He came up with the general theory of relativity, which George Gamow later dubbed the Big Bang Theory. And because when the Big Bang Theory was confirmed in 1929, Einstein rejected atheism. He said, there must be a supreme intelligent creative beginner to the universe. A lot of times we think of the Big Bang Theory as being a friend of atheism. It's actually the enemy of atheism. It caused Einstein himself to reject atheism. Einstein came up with the Big Bang Theory, and because of the Big Bang Theory, he rejected atheism. The other thing that's interesting about this curve is that out in the real world, no one cares about coming up with mathematical equations of coffee cooling down to room temperature. However, they do care about catching murderers, and this curve can be used to catch murderers. You see, it's usually not a cup of coffee that's cooling. It's usually it's a dead body that's encountered by a detective or an investigator. And they're not there at the point of death. They get called into the scene like here. And they come up with the equation of temperature of the dead body as a function of time so that they can predict backwards what the time of death was. Let's say the time of death was like, according to the curve, let's say it was 40 minutes ago. Then we can go back and take the suspects and see if they have an alibi for 40 minutes ago. So let's just do a warm-up question on that, because today's first hot dog question will be calculating time of death in a detective kind of crime scene setting so that you can figure out who has an alibi, who doesn't have an alibi for the alleged murder. So here we go. I'd like you to clear your desk of everything, surfaces, phones, lectures, calculators, everything up your desk. Except for your calculator you can have. So take out your calculator. Here we go. And you get a new hot dog bun. You know, you're wondering, why are you talking so long? Well, I'm trying to be heard out there in the YouTube land. So, hey YouTube. you're gonna get a new hot dog bun. Please put your group members' last names in alphabetical order in the upper right-hand
Are
corner.
we turning it on?
At the end of class, yeah, go turn it on. Actually, no, change my mind. You have your homework ready to turn in, just watch the camera, don't trip over the cable, but go ahead and turn the homework worksheet in to the table by the door as I distribute your hot dog bun. Yes, watch out for the cable, good job, okay, no, you're fine. People, don't interrupt the room. Here's your hot dog bun. Good. Hold it. Hot dog bun. Did you get your hot dog bun yet? Oh, there it is. All right, here we go.
No, just haven't seen it.
Now, quiz review. That's the name of this activity. It's Quiz Review Day. And we're going to take a look at a situation in which, that should show up well. All right, so this person walks in and normal human body temperature is 98.6 degrees Fahrenheit. It's actually some pretty old data. It may not actually be accurate. It's probably a little bit off because that's been around for a long time and measurement instruments have improved quite a bit. That's a problem we look at in AP Stats. Some of you might want to take AP Stats next year because the truth is you only need Algebra 2 as a prerequisite to take AP Stats. So it's much more likely that people will use statistics in the real world than calculus. Not afraid to say that publicly, but here we go. Suppose you walk in and 0 minutes after you walk in the room, you take the temperature of the body, it turns out to be 85 degrees Fahrenheit. 5 minutes later, the temperature of the body has dropped to 83.5 degrees Fahrenheit. Now, different bodies change in temperature. I mean, there's all sorts of factors. There's the amount of body fat, there's the amount of clothing. I mean, if the person is in like winter clothing, it's not going to cool as quickly. So it's not the same curve for every person. It's different for every person. That's why we need to make up a different equation for each person. Now, if this were a hot dog question, what you would have to do, I would want to see if you can come up with a linear model of the linear decay rate and an exponential model, both, to show that you know the difference between the linear models that we studied first semester and the exponential models that we're studying this semester. And by the way, hello, we've got linear exponential relays. The basic idea here is that in a linear model, if you're doing a linear function, then you know that we start somewhere called the initial output, and that we add something every so often. But in an exponential model, we start somewhere called the initial output, and we multiply by something every so often. So I want to see if you understand both of these. So here's how we're going to roll. If this had been the hot dog problem, then you would do this. You would say, look, we're starting at 85 degrees on both models. So both of them start out with y equals 85. Now, I'm going to write this down twice because we're going to analyze it from a linear perspective, and then we're going to analyze it from an exponential perspective. But if this were a linear situation, I would just want to find the rise and the run. By subtraction, these carets, these pointy symbols, mean subtraction. 83.5 minus 85 is negative 1.5. So the rise is negative 1.5, the run is 5. So if we lived in a universe where temperatures decayed linearly, they don't. Newton's law of cooling shows it's exponential decay, but if it were linear, we would say, well, we're going to add negative 1.5 to the temperature of the body every 5 minutes. Now, start somewhere, add something every so often. So this is not a calculator activity. Those of you on your calculators, go and put the calculators aside and write this on your collection of hot dog problems. It's kind of like a practice problem. So go ahead and write the linear equation of the function that passes through the point 0, 85 and 5, 83.5. Start somewhere, add something every so often. But what happens in reality is exponential decay. So this arc, that doesn't mean subtraction. The pointy arrow, that means subtraction. The arc means division. So we're going to multiply the ratio. The output ratio is the ratio of the outputs. Instead of taking y2 minus y1, I'm taking y2 divided by y1. It's almost exactly the same thing. Instead of an output change, I'm looking at an output ratio, the ratio of the outputs. So I'm going to start somewhere. I'm going to multiply by something, 83.5 over 85, to the x over 5 power. And if this were a hot dog question, the only thing you would write on the hot dog bun would be the linear equation and the exponential equation. We have a line that passes through these 2 points and an exponential decay curve that passes through these 2 points. If you were to put the graph on the graphing calculator, it would look like this: 85, and then 83.5. 5 minutes later, we're down to 83.5. So there's a line that passes through those 2 points, but there's also an exponential decay curve, which I have shown here in red, that passes through those 2 points. Both equations pass through the points 0, 85 and 0, 85 and 5, 83.5. One's linear decay, which is not how bodies cool off. The other is exponential decay, which is how bodies cool off. Now let's calculate the time of death. Take up your calculator and let's type in our equation. We're going to type it in right here. If you have your plot turned on, would you please put your cursor up on plot 1 and press enter? That's a toggle switch that will turn it off. So put your cursor up on plot 1, on, off, on, off. No, you don't want this. You don't want it turned on. You want this scatter plot turned off. And then come down and let's type in 85. That's got to start somewhere. This body temperature starts at 85. Got to multiply it by the output ratio. Got to multiply it by something. It's 83.5 divided by 85 in parentheses. Start somewhere, and we're going to multiply this by that fraction every 5 minutes. X divided by 5. Now, we have to think viewing window. Yes, question?
How do you get like that carrot thing? Because I just like a box.
Oh, you know what? Just so that yours is like everyone else's, go to mode and select classic. Because we're putting fractions in the exponents. You're in Algebra 2. You don't need the math print crutch anymore. You actually understand enough about mathematics that you can just go straight to classic mode and type it in like this. Math print is a crutch. All right.
I don't see.
You have to like go
So yeah, you might have to go up or go down to a different screen within the mode, but you'll find it in there somewhere. I'm really convinced.
I had to go. It doesn't work. I had to press up.
So, oh, this is interesting. I heard someone claim that it doesn't work. Wait, Thomas?
It just says invalid dimension.
Oh, that's because your plot's turned on. So what you gotta do is, we're just gonna go to the y equals menu, go up arrow, here, it's like this. Go up arrow to your y equals menu, put your cursor on, this is how your calculator looked when I observed it. Put your cursor up on plot 1 so it's flashing. And then press enter, back off of plot 1. It's turned off now. Now you're not gonna get error dimension stuff. Right?
Yeah.
Let's go to the viewing window. Now, we care about like the past 100 minutes. We figure temperature is 85 degrees. This guy could have died anywhere in the past 2 hours, maybe. Let's go back to 2 hours ago. That's negative 120 minutes. And let's also, I don't care much about the future. I care about what happened in the past. I'm a detective. I care about what happened in the past. Fine, we'll go 1 hour into the future, just for fun. All right, by the way, temperatures, let's go from negative 20 degrees Fahrenheit. Normal human body temperature is 98.6, so let's go up to 110 degrees, just in case, if they had a bad fever, that'd make it harder to figure this out. We're assuming the person did not have a high fever at the time that they died, which could be a bad assumption. Maybe they were sick, had a really high fever. So this is not the easiest thing to do, but we are going to go to the y equals menu and put a horizontal line at 98.6 degrees because that is normal human body temperature. We're gonna hit graph, and here's the show. Here's the body temperature coming down, it's cooling. It's an exponential decay curve. That's the time of death right there. So let's go to calculate intersect. Calculate item 5. First curve, enter. Second curve, enter. Guess, enter. We just discovered that this person, according to the model, died about 42 minutes ago. So now we can look at the suspects and see if they have an alibi for 42 minutes before I walked into the room and started taking the temperature of the deceased. Any questions on how to get negative 41.68 minutes ago for the time of death? Which is 41.68 minutes plus, that's 5 minutes. So, but 41.68 minutes before I made the first measurement. Okay, it's time for a hot dog question. By the way, this x over 5 thing, you realize that both of them have x over 5? Both of them have an 85? The only difference between the linear model and the exponential model is that the linear model, we add negative 1.5 every so often. In the exponential model, we multiply by the ratio 83.5 over 85 every so often. And in case you're wondering if that's legit, if we're really allowed to do that on an exponential model, check it out. In a linear function, you usually do b plus mx. Initial output plus. Here's the rise over run. That's just y2 minus y1 over x2 minus x1. That's just rise over run. Am I allowed to do this? Watch carefully. Don't let me pull a fast one on you. Am I allowed to bring the input change over here? Does that change it mathematically? Andrew, does it change it to say instead of, like for this problem right here that has a rise of negative 6 and a run of 5, can I make this negative 6 over 5 times x and then bring it over here and make it negative 6 times x over 5? Is that the same thing? Or is that different to move this over? No, it's the same. It's the same. It doesn't change it at all. It would be like this. It would be like saying 3 over 1, actually 3 over 15 times x. Is that the same thing as 3 times x over 15? If I move the 15 over, does that change it? No, it's still going to be 3x over 15. All right, so here we go. Hot dog question. I'm going to give you 2 points, 2 temperatures on a body discovered at a crime scene. Your job is to write a linear model and an exponential model on the hot dog bun. Show your work on the collection packet. Here we go. Okay, here's a crime scene. You arrive at the scene and you observe that the body temperature is now 93 degrees. And then 6 minutes later, it's down to 91 degrees Fahrenheit. Write both a linear model and an exponential model whose graph passes through these 2 points. Label them linear and exponential. Write the equations on the hot dog bun and get someone in your group to get everyone to sign off on it.
Yeah, this is when you're actually adding stuff. Yeah.
This is a
That's what I got. I got that.
Oh, can I take my bath? Can I actually pull my bath?
We needed other ones.
I know I do.
Or we take one.
Oh, I just.
I don't know, that's how you wrote it. I see it. Just write it.
Wait, for why would it be put up here? We didn't.
First,
Okay, that's not wrong. Good job.
second,
Okay, no, this is like, no, but the graphing for that. No, was it? It's so easy.
all right. Hey, nice work on this. Go ahead and start. Got a few minutes here. You've got about a minute before we start going, so you can start the yellow review packets. I've got the solutions to this yellow review packet online. In the homework solution module. Okay, now, for those who are participating, who are playing the hot dog game in the luxury and comfort of their own home, what you should have come up here with was, we're gonna start somewhere, we're gonna start 93. We're gonna add -2 degrees every 6 minutes. Start somewhere, add something every so often. Adding a negative is the same thing as subtraction, okay? Now, the exponential model is we start somewhere, we're starting 93 degrees. We're gonna multiply by the output ratio, which is 91/93 every 6 minutes. So that's to the x over 6 power. And you all got that. I'm so happy at you. Any questions on this? Now, just one follow-up here. On your exponential, or on your practice activity, in years past, they called it a practice quiz. No longer do we call it a practice quiz. It's a practice activity. Turn to the last page. Let's make sure that we can knock out let's talk a little bit about what's expected. For some of you, this will be the hardest part of the quiz. Let's look at number 17. So, Jay and Anna, if you direct your attention up here, flip forward to number 17. I think for some of you, this calculator anxiety will kick in. You might struggle with this a little bit. What you're supposed to do here is use the ordered pairs representing the graph above. Cross off the word above and replace it with the phrase to the left. Because if you look above, you won't find a graph. Search as long as you want, you won't find it, but there is a graph to the left. And so what you're going to have to do is estimate the coordinates of these points. Notice that golf balls 0, 1, 2, 3, and 4 are suspended in midair, defying gravity. And you have to estimate their altitudes. Golf ball 0 looks like, I don't know, 5.1, 5.2. You have to estimate it. Same thing with golf ball 1. Looks to me like 1.7. Someone else might write 1.65. The point is you have to estimate numbers for list 2. So, there it is. I picked 2.5, 3.2, 4.1. Do any of those look like ridiculous estimates, or are you okay with them in terms of the heights of the golf balls that you see? I don't know where they come up with all these golf balls, but they just keep coming day after day. Put them in list 1 and list 2. So take out your calculator, put the X's in list 1, put the Y's in list 2. Go ahead and start typing, and let's see if you can come up with the values of A and B using an exponential regression. Stat calculate 0, enter. See if you can find if there's any mistakes on this. Who knows? Maybe these are not correct. You just never know. So type in these numbers for list 1 and those for list 2. Run a stat calc exponential regression. So you gotta review this stuff, because for some of you this is going to be the hurdle that could trip you up. List 1 is 0, 1, 2, 3, 4. Hey, is anyone having trouble getting rid of the numbers that are in list 1 or list 2, and you want to know how to delete yesterday's numbers? Is anyone want? Yeah, okay. Look, if you want to get rid of yesterday's numbers, here's the procedure. Friends, here's what you do. Go to Stat Edit. You gotta put the cursor up on L1, and here we go. Dan, 2 keystrokes. Once the cursor is up on L1, do clear, enter, they're gone. Same thing with list 2. Put the cursor up there on L2. What are the 2 keystrokes, Dan?
Clear answer.
Clear, enter, they're gone. So now you can put in golf ball 0, 1, 2, 3, 4. It's amazing how fast this goes. And I want to display both of these simultaneously. Hopefully you've already typed in 5.2, 1.7, 0.5, 0.2, and 0.1. Make sure you have the same number of items in list 1 and list 2, otherwise you'll get an error mismatch or error dimensions. And just to get the values of A and B, you don't have to look at the scatter plot, friends. You don't have to turn on stat plot 1. You can do all of your quiz on Monday without ever getting the scatter plot on your screen. All you really have to do is stat, calculate, 0, enter, and check. Do they match up with what's on the solutions? 4.58 up, there it is. So that's, any questions on how to find A and B? Got to start somewhere and multiply by something every so often. Any questions on how to knock out A, B? Yeah, Thomas.
Wait, mine won't do it again. Where do you go?
Okay, so go back to list 1. Did you have the same problem yesterday?
Yeah,
And did we ever solve it? Yesterday?
I think so, but I don't remember how.
You have to go to L1, L2, and you have to make sure that you have the same number of numbers in each list.
But I can't get there. Like, it won't even open.
All right, so go to stat, and then enter, and show me what's on your screen. So there it is. Oh, so now you have to type them in. Now, yes, no, not stat count, just stat edit. And then enter these 5 numbers in list 1, those 5 numbers in list 2, and do a stat calc 0, enter. Yeah.
I did that in my graph.
No, we don't want to graph. We're just, first of all, making sure that you can do stat edit or stat calculate 0, enter. Did you get these numbers?
I tried to do that and this is what showed up.
Okay, let me take a peek at that. We've been, haven't found one that I couldn't solve yet. No, here, let's turn off. So, we're doing stat edit, you got the numbers, stat calc 0, stat calc 0, enter. There it is. Stat calc 0, enter. Okay. So, 3 decimals. Now, it looks like we're together on this. The next thing you're going to have to do on the quiz is use the curve to predict the height of golf ball 6. What is the height of golf ball 6? So here's the plan, friends. It looks like everyone has the equation. Go to your y equals menu and clear out everything. If your plot is on, turn off your plot. Who can remind me what button will bring up the equation here? Yes.
This is all that's coming up.
Okay, so just go. So you want to turn off your stat wizard. Believe me, your stat wizard, life will be easier if you make that wizard go away. Nothing against wizards, okay? But when you go to stats, oops. So if you could do stats calc 0, enter now, it's right there. It's right there for you. That way we're all doing the same thing. And no confusion. Who remembers what button to press right here? It's vars. So put your cursor next to the y equals menu, hit vars. What's the next button? Does anyone remember? You'll need this for Monday's quiz. Jack? 5 is correct. Now where? EQ. Regression equation, press enter. Let's set up our viewing window just like it is on our paper. Our paper is going like 0 to 10. Let's go 0 to 10 on X. And our Y's aren't very big, are they? They're just up to, so 0 to 10 on Y should be fine. Nothing fancy, 0 to 10 on each. Press graph. Yay! Exponential decay. That's just what we were expecting. Trace 6 and you're done.
Wait,
Yeah.
can you go over the thing
Yeah.
again?
From your Y equals menu, is your cursor right here?
Yeah.
Okay, so vars 5 is the statistics item.
Yeah.
Arrow over to EQ and press enter. There's your equation. All you gotta do now is a trace 6, enter, and there's your estimated height of golf ball 6. You'll have to be able to pull that off on Monday's quiz. You have not a practice quiz, but you have an activity to do. The solutions are online. You might be wondering, where, Mr. Royce, where are the online solutions? Well, in case you've never been to the homework module of Academy Central, and why is my phone hooked up to my computer? So we have, is it, I should be, I'm gonna decline that call. So, come on. That section of the video would go viral. But what you're doing, friends, if you're looking for the solutions to the review activity, just type in my password and go to the Algebra 2 course. And in Algebra 2, here's where you'll find it. All you gotta do is click on Solutions to Homework Assignments, and it's the very last one. In Solutions to Homework Assignments, there it is. Practice Solutions. Have a great weekend. Finish up your packet for Monday's quiz.